As a little small extra, I want to talk about the idea of images and inverse images of sets. And really, you can think about it as applying a function to a bunch of elements in your domain at the same time, and kind of in reverse, applying what's kind of like the inverse, but remember, in this case, f doesn't have to be bijective, but applying some sort of inverse to a subset of the codomain all at the same time. So let's define these things. Well, let's say we have some function around, and again, we specify no properties about this function. It can be whatever, one-to-one, onto, or not. And we have a subset of A, we'll call it C, and a subset of B, we'll call it D. Well, the image of this subset of A, C, under F, well, it's written like this, f of the subset. Well, it's all elements of B that are f of C. You just apply f to each element in our subset C, and you put them all in a set. The inverse image, and it's sometimes called the pre-image, that's another phrase you might see for this, the pre-image. It's like a generalized inverse in the way that the function doesn't have to be invertible for this to work. But the idea is, if you're taking the pre-image of a subset of your codomain, here it is here, D, you're looking for all elements in the domain that get mapped to those elements in your codomain. So it's all elements A in your domain such that f of A is something in that subset of your codomain you're talking about. Now, these might seem a little bit complicated, but just with a couple of examples, it should be fairly straightforward to see what's going on here. So let's look at the following. Let me scroll here. We have the following set. So we're thinking of A as the domain, and it's all natural numbers between 3 and 10 inclusive. So 3, 4, 5, 6, 7, 8, 9, and 10. And B is the set of numbers 1, 3, 5, 7, and 9. Okay, and I'm telling you how f operates. F of 3 is 7, f of 4 is 7, f of 5 is 1, f of 6 is 7, f of 7 is 9, f of 8 is 3, f of 9 is 1, and f of 10 is 9. So, if we're looking for f of the set containing 4, remember, the answer for an image, or this is the image of this subset, this set containing 4 is a subset of A here. It's the set of all elements that 4 maps to. Well, 4 is going to map to exactly one element. And we see here 4 gets mapped to 7. So this is the set that contains the number 7. Now notice that's different than saying f of 4 equals 7, because we're just applying f to just the element 4, and we get out 7. Remember, if we're applying f to a subset, like we are here, then our answer is going to be a set as well. It's kind of easier to see once we have a bunch of elements. So I have here 3, 7, and 9, and I'm going to put in 10 as well. So I have the subset 3, 7, 9, and 10 here. So I know that f of 3 is 7, so I get 7 in this set. F of 7 is 9, so I get 9. F of 9 is 1. And f of 10 is 9, but I already have 9, so I don't need to write it again. Remember, sets don't really have repeat elements in them. So the image of this subset, 3, 7, 9, 10, of our domain is the set 7, 9, 1. Okay. Now, the pre-image, all this is, it's all elements of A that are related to 7 and 1. So we check here. Well, f of 3 is 7. So 3 belongs in the set since f of 3 is 7. F of 4 is 7 as well. So 4 goes in here. What else do we have? F of 6 is 7. That goes in as well. So that's all of the elements that have that are related to 7. Now let's do the elements that are related to 1. So f of 5 is 1, so I'm going to put 5 in this set. And f of 9 is 1. So I'm going to put 9 in this set as well. And that is the pre-image of this set 7, 1. 7, 1 is, of course, a subset of our codomain B. And here is its pre-image, 3, 4, 5, 6, 9. Okay, now let's look at the pre-image of 5. We want all elements of A where f of that element gives us 5. And we look here, f of 3 is 7, so not 3, not 4, not 5, not 6, not 7, not 8, not 9, and not 10. So in fact, there are no elements in A where f of that element is 5, so the answer to this one is the empty set. Or if you like, you can write it like this, the empty set. And that's how images and pre-images work. Let's do another example on the next slide. Okay, so let's do something a little more complicated. So we have the set A. A has the elements 1, 2, 3, and 4. And we're going to define a function f, and f is going to have the domain be the power set of A. So remember, the power set is the set of all subsets of A, and the codomain is going to be A itself. So it's a function from the power set to the set itself, and we define it as f of whatever subset of A we put in here is the size of the subset union with the element 1. Let's make sure we know how this works with an example. So let's say X is the subset of A. Let's do 2, 4. Then F of 2, 4 is, well, it's the size of 2, 4 union 1. And 2, 4 union 1 is the set 1, 2, 4. And the size of 1, 2, 4, the cardinality, is, of course, 3. So the set 2, 4, remember, that's an element of our domain. That gets mapped to 3 in our codomain. So that's how this works. And as a little exercise, you can check that f of 1, 2, 3 also equals 3. So try that one yourselves, just to make sure you know how it works. Now remember, and this is important, elements of our domain are sets. They're subsets of A. So when we're talking about an image or a pre-image, it's going to be a set containing elements of the domain. So it's going to be a set where the elements are subsets, like here. Here we have a set containing the subset, the empty set, and the subset 2, 3. Okay, so maybe pause the video, try this yourself, and see if you can get this. Okay, now that we're back, well, let's put in each of these sets into F. So let's find, or maybe I'll write it like this actually. Let's find F of the empty set. Well, that is the size of the empty set union 1. And the empty set union 1 is just the set 1. And how many elements does 1 have in it? It has, of course, 1 element. So we have 1 in our set. And we need F of 2, 3. And this is the size of 2, 3 union the set with 1 in it, which is, well, it's going to be, this is the set 1, 2, 3. And the number of elements in 1, 2, 3 is, of course, 3 elements. So the image of this subset of the power set, each element in this set is an element of the power set, so it's a subset. This is 1, 3. Okay. So that was 1. Let's do 2. Let's do the preimage of 1. So we need all elements of the domain that get mapped to the number 1. Pause the video, see if you can figure this out. Okay, now that we're back, well, we need that the size of X union 1 to be 1, to be in this preimage. And the only elements of the power set that do this are the empty set or the set 1 itself. If there's any other element but 1 in this set, well then X union 1 is going to have more than 1 element. If you have a 2 or a 3 or a 4 in X, then the union here is going to have a 2, 3, or 4 in it as well as the 1. So the size of it is going to be bigger than 1. So the 2 elements of the domain that get mapped to 1 are the empty set and 1. And remember, these guys here, these are elements of our domain. They happen to be sets, but that's because the elements of our domain are sets. All right. So again, we have to figure out the inverse image of the set containing 2. Okay, so we need all subsets of A that get mapped to 2. So, what's this going to look like? We'll do 3 over here. We need that X union 1 equals 2. So, what could this be? So this means that we want X union 1. So this could be maybe 1, 2. It definitely has a 1 in it. So it could be 1, 2, 1, 3, or 1, 4. So what sets give us 1, 2, 1, 3, or 1, 4 when we take the union with it? So this means that x, well, it could be 2, 3, 4, or it could be 1, 2, 1, 3, and 1, 4. So x could be any one of those. So this pre-image is a little more complicated, but that's okay. So we have the element 2, we have the element 3, we have the element, I should say the element, the set containing these, so the element, the set containing 4. Remember, these guys here are elements of our domain, which is the power set, so they are subsets of A. And we have 1, 2, 1, 3. Oh, that looks kind of messy. Let me erase that and draw it again. 1, 3, and 1, 4. So that set containing the elements, the set containing 2, the set containing 3, the set containing 4, the set containing 1, 2, the set containing 1, 3, the set containing 1, 4, those 6 elements, which are subsets of A, so elements of the power set of A, these all get mapped to 2 in the codomain, and they're all of them, so this is indeed the inverse image.